Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two word problems using chain rule of derivatives. So let's start with the one on the left side. So for what values of x do the curves y equals 1 plus x cube exponent square and y equals 2x exponent 6 have the same slope? Now we have to understand that the slope of a curve is found from the derivative of the equation for that curve. Now in this problem we have to find the x values where these two curves have the same slope. That means we have to find the derivative for these two functions and then we have to set them equal to each other to find the x values. So let's start with the first function, y equals 1 plus x cube exponent 2. So y equals 1 plus x cube exponent 2. So the first step here is to find the derivative of this function, and for this function we'll have to use chain rule because this function has an inner function which is 1 plus x cube and the outer function is the exponential function with exponent 2. So we start with the derivative of the outer function. So we're using the prime notation. So y prime equals. So for the outer function, we'll use the power rule. So we'll move the exponent to the front and then we'll subtract 1 from the exponent times the derivative of the inner function, which is 1 plus x cube. So the derivative of the inner function is 0 plus 3x squared. So 1 is a constant, so that's why its derivative is 0. Now we can simplify this expression. So y prime equals, now in the second parenthesis, 0 plus 3x squared is just 3x squared. So we'll do 2 times 3x squared, which is 6x squared, and then parentheses 1 plus x cubed. Now the exponent 2 minus 1 is just 1 and we don't write 1 as the exponent. So this is the derivative of the first function. Now we can find the derivative of the second function. So the second function is given as 2x exponent 6. Now we can use the power rule to find the derivative of this function. So we'll use the prime notation, y prime equals. So 2 stays as it is because of the constant product rule. And then for x exponent 6, we can use the power rule, which will be 6x times 6 minus 1. And this can be simplified to 12x to the power 5. So this is the derivative of the second function. Now we have to find the x values where the slopes have the same, where the curves have the same slope. So we just have to equate these two derivative expressions and then solve for x. So we get the equation 12 and then x to the power 5 equals 6x squared times 1 plus x cubed. Now the next step is to simplify this equation. So we can distribute 6x squared in the parentheses. So we get 12x5 equals, so 6x squared plus 6x exponent 5. Now we can move both of these terms to the left side of the equation. So 12x exponent 5 and 6 exponent 5 are like terms. So we should subtract 6x exponent 5 from both sides. So 6 exponent 5 on the right side will cancel each other out. So we get, so 12x5 minus 6x to the power 5 will be 6 x to the power 5 equals 6x squared. Now we can subtract 6x squared from both sides. So we are doing this so we can set the equation equal to 0 and then solve for x. So on the left side we get 6x to the power 5 minus 6x to the power square equals 0. Now we can factor this equation. So we can factor out 6x squared. So we are doing common factoring and we are left with x cubed minus 1 equals 0. So now we get two cases. So the first case is 6x squared equals 0. And from this we get x equals 0 because if we divide both sides by 6, we get x squared equals 0, which is equivalent to x equals 0. So that's the first x value at which the curves have the same slope. Now we can analyze the second case, and the second case is x cubed minus 1 equals 0. So we isolate x by adding 1 to both sides. So we get x cubed equals 1 because the ones on the left side will cancel each other out. And now we can apply cube root to both sides to change x cubed to x. So the cube root and the cube cancel each other out and we get x equals 1 because cube root of 1 is equal to positive 1. So these are the two x values at which the curves have the same slope. So now we are done with the first problem and now we can analyze the second problem. So we have to find the equation of the tangent to the curve y equals x cubed minus 7 exponent 5 at x equals 2. Now we know that the tangent is a straight line. So the general equation of a straight line in slope-intercept form is y equals mx plus b. So in order to find the equation of this line, we need the m value and the b value. The m value can be obtained from the derivative of the curve because that derivative represents the slope of the tangent line. So the first step is m equals, so prime y, so I'm using the prime notation, and now we have to find the derivative of x cubed minus 7 exponent 5. So we have to use the chain rule because this function has an inner function x cubed minus 7 and then the outer function is the exponential function with exponent 5. So we start with the derivative of the outer function and we use the power rule. So the exponent 5 moves to the front and then x cubed minus 7 and then 5 minus 1 times the derivative of the inner function, which will be 3x squared minus 0. Now we have to find the slope of the tangent at x equals 2 because that's the point where the tangent touches the curve. So in the next step, we can sub in x as 2. We do not have to simplify this expression first and then sub in x as 2. So that will save us some time and steps. So we get 5 and then parentheses 2 cubed minus 7 and then we can simplify the exponent to 4 and then times 3 times 2 squared and the 0 goes away. Now we have to simplify this expression. So m equals 5 and then parentheses. So 2 cube is 8. So we get 8 minus 7 exponent 4 times. So 2 square is 4 and 3 times 4 is 12. Now in the next step, we can simplify the terms in the parentheses. So 8 minus 7 is 1. So 1 exponent 4 times 12, and 1 exponent 4 is just 1. So 5 times 12 is equal to 60. So this is the slope of the tangent line. So now we can rewrite the equation of the tangent line with the slope value. So 60x plus b. Now we have to find the value of b, the y-intercept. And for that we need a point. So we'll use this point for which we are given that the x is equal to 2, because this is the point at which the tangent touches the curve. So this point lies on both the tangent and the curve. So the first step is to find the y coordinate of this point, and for that we'll sub in x as 2 in the given equation of the curve. So we get y equals 2 cube minus 7 exponent 5, which can be simplified to, so 2 cube is 8, so 8 minus 7 exponent 5, which is equal to just 1, because 8 minus 7 is 1 and 1 exponent 5 is just 1. That means the point 2, 1 lies on the tangent. So now we can sub in x as 2 and y as 1 and solve for b. So we get 1 equals 60 times 2 plus b, and now we have to solve for b. So we'll multiply 60 and 2, which is 120 plus b, and now we have to solve for b. So 1 equals 120 plus b, and now we have to subtract 120 from both sides to isolate b on the right side. So 1 minus 120 is negative 119. So this is the b value for this equation. So the equation of the tangent line is y equals 60x minus 119. So this is the equation of the tangent line is in slope intercept form, and if you want you can also change it to the standard form. So these are the steps you have to keep in mind to solve these two types of problems. So for both of these problems we had to use chain rule to find the derivative of the equation of the curve. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.